Hi, I'm Mark Nord of Emerson Process Management. Today I'd like to talk to you about the Fisher DVC6000 and some of the diagnostic features that are available in it that might help you operate your plants a little bit more reliably. These DVC6000s have been out for approximately 8 years, and most people use them only for a valve positioner, but there's one very important function called performance diagnostics that people can use to make their plant operate more reliably. What I'm going to talk about here today specifically is some diagnostics that we can use to detect whether or not your actuator diaphragm is in good condition or not. The first thing we're going to talk about is this is a graph of the air consumption of a valve that has a good actuator diaphragm, and you can see from this graph that the airflow rate through the DVC6000 is between 5,000 and 6,000 standard cubic feet per hour. This is a normal flow rate that we would expect to see through a valve with a good actuator diaphragm. Also, you see that we have a green light or a green check mark down here that tells us simply that the valve is operating as we would expect it. Now, in this particular example, we're referencing a SIP blower valve that was installed at a power plant in the Midwest that had an issue with the actuator diaphragm going bad. This next graph shows that the air consumption has increased to approximately 220 standard cubic feet per hour. This is well in excess of what we would expect from a standard control valve. And you can also see that we now have a yellow light down here which says the control valve is still operating properly, but it's operating outside of its normal range and you need to give it some attention soon. Once the customer found this problem, they were able to go out, they disassembled the valve, they took the actuator diaphragm off, and they found that the actuator diaphragm was full of checks and cracks that was allowing air to leak through out into the atmosphere. The valve was reassembled with a new actuator diaphragm. The leakage rates went back to the normal 5 to 6 standard cubic feet per hour. And the most important part is the problem was caught before the actuator diaphragm failed and possibly tripped the plant. So in summary, I've shown that the DVC can be far more than a valve positioner. Using performance diagnostics, we're able to solve a problem that could have potentially tripped a plant. If you'd like more information, you can go to the internet at FIELDVUE.com, and thank you for your time.